Okay, Bismillahirrahmanirrahim. Assalamualaikum and very good day everyone. For this first lecture, we're going to look at normal distribution. Yeah, this is a very important topic as I mentioned to you during our first session last Thursday. Yeah. So in this lecture, you will learn how to compute probabilities from the normal distribution, how to use normal distribution to solve business problems. You will learn how to use the normal probability plot to determine whether the set of data is approximately normally distributed. To compute probabilities from the uniform distribution. And lastly, normal approximation to the binomial distribution. Perhaps we're going to firstly look at normal distribution first, yeah, for this particular lecture. Now, under the category of continuous probability distribution, we are looking at continuous variable, yeah. The variable under the continuous probability distribution is the continuous variable. So a continuous variable is a variable that can assume any value on the continuum. Yeah. So it means that it can assume an uncountable number of values. Yeah. So for example, even though those numbers are not countable, but you can actually measure, yeah, measure those values, those variables, and you can get some values. Okay, so for example, the thickness of an item, the time required to complete a task, temperature of a solution, or even height in inches or in centimeters, so on and so forth. So this potentially can take on any value depending on the ability to precisely and accurately measure the variable. So if we can measure this variable, then you can assume you can get some values out of those continuous variable. Yeah. Now continuous probability distribution can take several shapes. Yeah? So the most widely used is the normal distribution. So normal distribution has a symmetrical shape. Yeah, the shape is symmetrical, and normally the shape is called a bell shape because it looks like a bell. Yeah, and the values of this normal distribution range from negative infinity to positive infinity. The next category of continuous probability distribution is a uniform distribution. Yeah? So for uniform distribution, the shape is normally rectangular. Yeah? It is also a symmetrical shape, yeah, and every value between the smallest and the largest is equally likely. Yeah, so meaning to say, in general, the values of x under the uniform distribution has equal probability to be occurred. Yeah. The last one is the exponential distribution. Yeah, this is a right skewed type of distribution on which the value of its means is larger than the value of median, and the value range from 0 to positive infinity. Now coming back again to normal distribution, where we know that the shape is bell shape and it is symmetrical. Yeah, so it is a bell shape distribution and it is symmetrical, such that if you were to divide this normal shape, yeah, this bell shape, this distribution, you can get an equal size and shape, yeah, if you were to divide the normal distribution into two. Now, for a normal distribution, we will know that mean, mode, and median for this particular distribution are actually equal. Yeah. So we have looked at these features. Yeah. Earlier on in the in earlier course under statistic 1. Yeah. Where we say that the normal distribution has the value of mean, median, and mode, which are very basically the same to each other. The location is determined by the mean value denoted by mu, and the spread is determined by standard deviation, sigma. Yeah. So the spread meaning the dispersion. So how you measure the dispersion of this normal distribution is actually through the value of its standard deviation. Okay. And the random variable has infinite theoretical range from negative infinity to positive infinity. Yeah, meaning to say that the bell shape can never cross the x-axis. Yeah, it will either go towards the left infinitely or towards the right, but it can never touch the x-axis. So this is an example of a normal distribution. So basically, we have done histogram in our stats 1. So if you were to have a histogram with this sort of shape, so you can say that the distribution of these values are actually normally distributed. Okay. Now, the normal distribution density function. The formula for the normal probability density function is given by this formula. Yeah. So in this formula, E is the mathematical constant approximated by the value equals to 2.71828. Pi is the mathematical constant approximated by a value equals to 3.14159. Mu is the population mean. Sigma is the population standard deviation, and X is the value of continuous variable. It can take any value for that matter. Yeah. Now, by varying the parameters mu and sigma, we obtain different normal distribution, different shape, yeah, or different types of normal distribution. Yeah. So this type can the type of normal distribution, it can be a more scattered, yeah, distribution, or more concentrated towards the mean. Yeah. So distribution A, denoted by this blue dotted line, have the same mean with distribution B. Yeah, distribution B is shown by this red line. Okay, so these two distribution A and distribution B, has the same mean. This is the mean value of distribution A and B, but they have different value of standard deviation. Yeah, because if you look at distribution A and distribution B, they have different spread. Yeah, spreadness. A is more scattered, B is more narrow towards the mean. Yeah, so for A and B, they have the same value of mean but different standard deviation. Now if we look at distribution B and distribution C, distribution B, again, this is the solid red line, and distribution C is the solid blue line. Okay, these two distribution has different means. Yeah, one with this value of mean, distribution B has this value of mean, and distribution B has this value of mean. So they are actually of different means. Yeah, and they also have different standard deviation. Yeah, again, because if you look at distribution B, it is more narrow towards is mean, and whereas for distribution C, it is more dispersed, yeah, more wider and more scattered away from its own means. Yeah, so we're saying that distribution B and C have different means and different standard deviation. Okay. Now, so we have been looking at a normal distribution shape here. If we were to change the mu or the mean value of a normal distribution, the distribution will shift from left to right, yeah, accordingly. Yeah, if you move the value, if the value of mean is larger, meaning the normal distribution will move towards the right. Okay, you will move towards the right. The larger means, meaning the distribution is will be on the right side. It will move to the right side. Okay, the smaller the mean, the normal distribution will move to the left. Okay. Now, if you were to change the value of sigma or the standard deviation, yeah, it will either increase or decrease the spreadness or the dispersion. If the value of sigma is larger, meaning you're going to have a more dispersed normal distribution. If the value of standard deviation is smaller, yeah, or small compared to the other value of standard deviation, then this normal distribution will be much narrower. Yeah, it will have a more concentrated towards its mean value. Yeah, it will be a narrower distribution. If the mean standard deviation value is larger, then the spreadness will be larger as well. Okay, it will be more dispersed. So any normal distribution with any combination of mean and standard deviation can be transformed into the standard normal distribution. Yeah, standard normal distribution is also known as the Z distribution. Okay, so but before that, why do we need to transform a normal distribution into a standard normal distribution? Yeah, so the answer is because if we were to measure the probability for a normal distribution, yeah, you have to use the standard normal table. Yeah, so in order to use the standard normal table, which only consists of the value of Z, yeah, you have to convert or you have to transform the normal distribution into a standard normal distribution. Yeah. So to compute normal probabilities, you need to transform the unit of X into Z unit. Okay. So under any normal distribution, you can take any value of X. Yeah. So we have looked earlier on where normal distribution is a continuous distribution for continuous variable. Yeah. And the units can be in terms of millimeter, can be in terms of inches, kilogram, gram, so on and so forth. Yeah. But in order to compute the probability of normal distribution or the normal probabilities, you have to have a standard value. Yeah. So for this reason, you must transform the value of X unit into Z unit. Okay. So under the standard normal distribution Z, the value of mean is equals to 0 and standard deviation equals to 1. Yeah. For a any normal distribution, we are saying this is a distribution of X. Yeah. distribution of x. X can take any value. But if you were to transform the normal distribution of x into z normal distribution or standard normal distribution, standard normal distribution only has mean value equals of 0 and standard deviation equals to 1. So to transform or to convert to standard normal distribution, there's a formula that you can use. Okay, so you can transform you can transform x into z by using this formula. And to be able to do that, you must have the value of mean and standard deviation for the x distribution. Okay, so the formula is simply z equals to x minus mu divided by standard deviation. Remember, the distribution of z always has mean equals to 0 and standard deviation equals to 1. Okay, for x distribution, it depends on the x distribution itself. It will have its own value of mean and standard deviation respectively. But for z distribution, mean is always equals to 0, standard deviation always equals to 1. Now, you have looked at the probability density function for normal distribution. So the formula for the standardized normal probability density function is given by this formula, okay, which is slightly different from the probability density function for normal distribution, on which we have looked at just now. Yeah. So under the standardized normal distribution, which is also known as Z distribution, we must remember mean is always equals to 0, standard deviation always equals to 1. Yeah, as I have mentioned couples of times before this. Yeah. So again, this is the distribution of Z, and this is the frequency distribution on the y-axis. So for all standardized normal distribution, mu will be equals to 0, standard deviation will be equals to 1. And all the values above mean, which is equals to 0, will have positive value of z. However, if the values are below the mean equals to 0, x will have the negative values. So now let's look at the example. If x is normally distributed or distributed normally with mean equals to 100 and standard deviation equals to 50, we can find the value of z. Yeah? We can find the value of z for x equals to 200. Yeah? So x equals to 200 is from a normal distribution, and now we would like to convert this x into z value. Okay? In order to do that, we can use this formula as we have looked at just now. We can convert x to z by using this formula, z equals to x minus mu and standard divided by its standard deviation. We have known from the question that the mean value of x is equals to 100 and its standard deviation is equals to 50. So we would like to know what is the z value of x equals to 200. So in order to get the z value, we simply take x equals to 200 minus mean value equals to 100 divided by standard deviation equals to 50, and we will get 2.0. Okay, so this says that x equals to 200 is standard deviation or 2 increments of 50 units above mean of 100. Yeah, because we know in Z distribution, or standardized normal distribution, mean is always equals to 0, standard deviation equals to 1. Therefore, when when z equals to 2, it means that the value of x equals to 200 is 2 standard deviation above mean equals to 0. So if we were to plot this in terms in a diagrammatical form, yeah, we know earlier on that the x distribution has mean equals to 100 and standard deviation equals to 50. So we like to know what is the value of this z for x equals to 200. Okay, so we have done the calculation. When x equals 200, the standardized z will be equals to 2.0. So this 2.0 is actually the value of z for x equals to 200. So note that the shape of the distribution is the same, only the scale has changed. And we can express this in the problem of the original units, x in dollars or in standard units, which is z. Okay, so if we were to have the diagram, yeah, or the plot or the sketch of plot for x and z distributions, they will be exactly the same. It's just that for x distribution, you will denote the variable as x. But if you were to use this sketch of normal distribution of z, the value will be mean equals to 0 and x will be equals to 2. And this distribution is actually a z distribution. Okay.